I am Jason Pontius, the Director of Operations for Smart Monkeys. And we are a show control company. I'm going to kind of skip past this slide because he just read it to you. But we do specialize in show control, media management and control, networking, and data management and data mining of some of the AV systems. We've done over 200 projects in our 14 years or so of a company. And some of those examples would be the Bradley Terminal at LAX Airport as a media type of installation. The Warner Brothers Abu Dhabi theme park, fully indoor theme park. We did the show control for the entire theme park there. The Spectacle at MGM Cotai in Macau, another very large media and media management project. The Radio City Rockettes Christmas Spectacular. We do the show control for that show as well. And we have a gentleman there right now as we get prepared for tech rehearsals. This is a Orlando Airport expansion project where there's interactive video features that will be kind of highlighted in that airport terminal. And for some of you may be familiar with the Qatar Hotel at the Hard Rock Hotel and Casino in South Florida. The LED on the outside of the building is not ours, but we do provide the platform that runs and controls that LED. So there's some example of projects that we've worked on. So today's topic of our presentation is show control, thinking outside the box, the future of large scale solutions. And today we're going to be talking kind of a high level discussion on some of the architecture and things that go into providing such a solution. There are many topics that we'll touch on briefly that we could go into a much further detailed conversation about. And if any of those tend to pop up and show interest in, maybe this afternoon at coffee chat, we can go into more detail on some of those. So I want to remind you that we're talking about large scale projects. We're not talking about small and mid-sized projects. We're talking about a very small percentage of overall projects that get done every year in the industry. But these projects tend to be very high profile. They're very critical, large, well-known clients. So it's very important that you can develop a solution that will meet the needs of these particular unique projects. But before we kind of dive into what this looks like, we kind of have to understand what show control is in the first place. So how many people kind of have an idea of what show control is? A couple, kind of, maybe? Right, so it's simply defined as the use of automation technology to link together and operate multiple entertainment systems in a coordinated manner. So it's distinguished from what we call a subsystem controller in that a subsystem controller would control a specific system or element within a show, such as a lighting controller, something set like a sound processor, a video controller, or rigging or pyrotechnics controller. Those are specific to their disciplines. Show control is what ties it all together and coordinates and synchronizes the activities of all of these together. One analogy that I like to use is one of an orchestra. So an orchestra has multiple sections: brass, woodwind, percussion, strings, and within that they have individual players and instruments. The conductor is the one that keeps everyone in sync and playing together, and it kind of helps cue when their entrances are. That is the role of show control. It is to control or synchronize all the players and all the activities that are going on to result in a smooth and synchronous project or show. So how have we been doing this in recent years? Well, for the past few decades, a lot of this has been done with a single entity controller. So we're going to refer to that as the box. And again, our topic today is thinking outside the box. So let's define what the box is. So individual either hardware or software show controllers that control end devices. And some examples would be Medialon Manager or their Showmaster product, Alcorn McBride V16, QLab, which I know you have on in the theater here and on campus, and Crestron controllers, which are pretty popular in conference rooms and boardrooms, and I've seen some here as well. These are great for small to mid-sized projects. If you have one venue or one small mid-sized museum, these work great for that. But they have their limits. And so eventually you have to figure out, well, how do we go beyond one of these controllers into something that's a bigger solution? But with these, there are definitely some benefits to them. So the first is going to be cost effectiveness. They're not really that expensive compared to, or let's say in the big scheme of things, they're not super expensive. They're simple and straightforward. It doesn't require much. They're easy to learn how to program. It doesn't take a rocket scientist to figure out what to do with these. And there's minimal required infrastructure. So usually it's a small device or a piece of software. It's going to run on a computer or its own box. You're going to install it into an equipment rack, plug in some power, plug it onto the network, and you're pretty much there. You're good to go. There's not a lot of specialty requirements in implementing them. But with this comes some limitations. And one of the limitations that we run into is there's no built-in redundancy. There's no inherent fail-safe method of having a redundant controller or a redundant process. So yeah, you can go and you can buy a second unit and you can have a backup controller sitting in your rack. And when the first one dies, you can kind of get the second one up and running, but it's not going to be smooth. You're probably going to lose that show that you're in the middle of until you can get the backup running. Now, in the past, there's been ways to do some really fancy programming to kind of make them both available and online and kind of switch from one to the other, but it's very difficult and it's a little clunky. And we don't do that very often. It just doesn't always work in a seamless fashion. A lot of these controllers don't really scale well. You know, again, they're fine for small and mid-sized projects, but when you get up to a very large project where you're looking at hundreds, if not thousands of endpoints and end devices and systems you're controlling or monitoring and pulling data from, they're going to eventually hit their limits, right? Whether it's processor power, memory, software limitations, eventually you're going to hit the ceiling and it's just not going to be able to deliver on a large scale. I've seen some times where people will design a system where there's multiples of these. So let's say that there's 6 different repeated controllers. Each one's going to focus on a certain part of the project or the show or the venue. And then maybe there's one on top that talks to all of them and kind of coordinates between them. It's possible, but it gets really clunky. And now you've got to worry about redundancy across many units instead of your main system. Another limitation is a single programmer architecture, and we're going to see why this applies a little bit later. But these are designed for one person to come in, open their laptop, get on the software, and program that venue, that project, that show, which is fine. But when we start talking about a large project where you've got multiple productions going on and multiple designers and programmers, you're going to want to be able to access and set up queues and do show queues at the same time. And these aren't really set up for that. So how do we overcome these limitations on these larger projects? Well, I think the best way to do this is to take a case study and let's walk through what that might look like. So we're going to go beyond the box now and take a look at how do we approach a very large project that we have to come up with a solution for. In this case study that we're going to talk about, we're going to call this a large live performance venue. So let's assume that this is a big arena performance space. There's going to be 10,000 seats. You're going to do some really big shows in here. And so we're going to have to control a lot of things over a very large building. And we're even going to have a programming room where we can go and program queues for the next show or the next version of the show without affecting the current show that's running in the main theater space. So let's say that next week we know that one of the performers are going to be swapped out, or an act is going to be swapped out, or a new show is coming in. We can go in and we can start programming and mocking it up in the programming room and building all the cues for that show and save them and have them ready to go. So Sunday night, when we do a swap out for the show, we're ready to go. And it doesn't affect what's going on in the performance space itself. So that's our venue. That's our case study that we're going to take a look at. So the first thing that we need to understand are what are the requirements. Before you can ever design or deliver a solution, we have to know what the requirements are that we're trying to achieve. So our first requirement is that we have to have a system that's resilient. It's fault tolerant, both at the hardware level and the software level. We want to be able to recover from failures and not have it bring our show down. And to do that, we're going to build in redundancies. Certain elements are going to be repeated or have backups built into them so that we can make sure that if there is a failure, we can still keep going. The system will continue to run. We want to be able to scale. Again, we're talking about the scale of the project. We want to be able to scale up to being able to handle many, many devices, many subsystems, talking to, commanding, receiving information, feedback, and data in real time from over 1,000 devices at once. And so that requires a lot of overhead and a lot of processes to make that happen. We want to, as I was saying before, we want to be able to simultaneously program. The lighting programmer, the audio programmer, and the video programmer, they want to go in and set up their show cues at the same time. We don't have endless time for our production cycles to go into the theater and have one person go in at a time and program the show and put in their show cues. So let's make it so that they can all edit show cues at the same time, and those all get stored into the system and can be played back for the show. We want to be able to execute these cues from multiple sources or devices that trigger the playback of these cues. And we'll go into a little bit more of that in a moment. And very important is we want to have a high level of system monitoring. The bigger the scale is of a project or a system, the more important it is to have that monitoring, that feedback of what's going on in your system. So in this space, it's a large space with a lot of equipment, a lot of things going on. You can imagine how much audio, for example, is in this venue. So we're not going to have someone running down to the equipment room and going through 99 different amplifiers to make sure they're okay. So we need to have all that feedback coming back. Let's assume that there's LED. I know over here in the theater, they've got an LED wall going in for the Christmas production that's being loaded in. How do we know that the tiles are okay? How do we know that one LED tile in that whole space is not overheating or dropped offline? So all that feedback needs to come back into the system, and not only in real time, but to store that data so that over time we can see what happens. You may come into the theater during the day and say, why is this one issue over here happening every day? And you realize because you're logging all that data and you're tracking it and you're even graphing it, you can go back and look and see, wow, we see that every night between midnight and 2 a.m., all of our equipment is overheating. And we realize that the building management system was set to turn off the AC at midnight. So all of this information is very important to be able to manage your system that you're putting in and all the other subsystems that are running in the building as well. So that's kind of what's required. The first thing we want to look at is our physical setup. What is our physical equipment that everything's going to run on? We need to have fault tolerance here at the physical level. Let's not worry about software right now. We're talking about the actual hardware itself. Very key is we want a redundant network. We want network A, we want network B. That means multiple sets of switches, multiple cable paths, multiple connections to all of your equipment. You don't want to have in a facility like this, let's say we're doing a big concert special event every night in this 10,000 seat auditorium, and Saturday afternoon, they're loading in a new set or something, and a truck forklift driver runs into a conduit and just damages all the fiber on the network. You don't want that to bring your whole show down for the next week while you rerun your fiber. So very important to have two networks with two different paths of your infrastructure, cable and fiber. You don't want a network switch belly up and all of a sudden brings your whole system down. Everything is so reliant these days on network. It's very important to have an extremely resilient network infrastructure. Then we have the system hardware itself. What is the equipment that the software and the processors are going to run on? So this is the computers. This is the physical devices that we're running. We want to make sure that they have redundant components. So if it's a computer-based system, does it have a dual power supply? Does it have a redundant array of hard drives? You don't want a single hard drive to come bring your whole system down, because you know it's going to happen. It's not a matter of if, it's a matter of when. Is it next week? Is it a year from now? You don't want that to happen. Redundant power supplies and power sources. Someone accidentally turns off a breaker, something like that. Again, you need multiple points of power, multiple power supplies, multiple hard drives, multiple network connections into your computer systems, and so forth. And then there's a concept of server clusters in virtual machines. And I don't know how many people here kind of know what that's all about. It's been happening in the IT industry for years, and we've been adopting that in the entertainment side, and Smart Monkeys has been doing this now for over 10 years, in that we're taking that concept of an IT structure of clustering servers together to act as one virtual server, And then within that, running what's called a virtual machine. Let's say you have software that runs on a Windows OS. So we can create virtual PCs or virtual Windows applications running inside this larger virtual server. And what that does is now when one server were to die, and again, we have dual power supplies and so forth, but let's say that server just takes a dump. We have other servers in that cluster still running, and those virtual machines can be spread across to where they are redundant in real time. So very fault tolerant at the physical level. Now we don't have our whole system going down because of one hardware failure, whether it's in the network or the computers themselves. So now we have our hardware. We feel really good about that. Now we need to talk about our software. What is going to be running on this hardware to be able to control our venue? Well, in the traditional system that we talked about, we had the box, right? We had one controller and it talked to all the show elements. We programmed our video playback and we queued the lighting controller and so forth from this one box. Well, we're going to move beyond the box now, and we're going to take this concept of the box being a show controller, and we're going to say that, no, we're going to go to a platform, which means it's going to be a collection of different services, different layers that come together to work together to create a solution beyond just one entity controller. So let's take this concept, we're going to deconstruct it a little bit into some core functionalities. And for this, we're going to talk about three core functions. First is the triggering interfaces, and those are the things that actually make the cues go. They could be a button, it could be a touch panel, it could be a number of things that actually fire off cues or sequences of cues or a whole timeline of events. And those events are in our cue sequencer. The cue sequencer is what's going to store all of the information that it needs to do timely playback of cues that are triggered from the triggering interfaces. And we've separated out now the device server, which is the actual part that talks to the end devices and subsystems and things like that. The device server is where we keep track of what is that API, what is that command that that video server needs to get to be able to play back its video. So there's a lot of advantages and things that this offers when we break this up into different layers of functionality. Again, our triggering interfaces can be a touch screen, it could be physical button panels, it could be time code, it could be third-party control. A show comes in, a road show comes in, and maybe they want to have their lighting console trigger the playback of each scene, and that's fine, we can handle that. The cue sequencer is where we store our show cues, and I use the term here friendly cues because what we're going to put here is not the actual message that goes to the hardware itself, but the message that you as a show programmer want to know. For example, let's say you open your show, your first scene, you're going to play back a video file onto the LED wall. You don't want to send some archaic command message to the video server. You want to say, play video track 1. And that's going to be your show cue, because what you care about here in show cues is timing, the sequence of timed events or a timeline that actually is the cues relative to this show, not so much what the hardware wants to be told. So then we get to our device server. Here's the part that actually talks to the hardware. It has the communication with all of those end devices, all those subsystems, and it knows what that API or those messages are that it needs to send, whether it's a checksum, whether it's whatever that protocol is. That's where we store that. And it provides a couple of huge advantages. First is portability. So when we separate the show cues from the actual hardware messaging, we now have a show that's programmed in the show cue and the cue sequencer that we can transplant to another venue, because that's our timing. That's what the performers know. That's what the director knows. That is our timing for our show. And we can move it. Let's say we have this facility in LA, and maybe there's another one in Vegas and another one in New York. And we're going to take that same show that we started in LA. A month later, we're going to launch it in Vegas. And a month later, we're going to launch it in New York. We can take the show itself and we can move it from venue to venue, and we already have it programmed. A little tweaking and we're good to go. What is dependent on each facility is the end hardware, the end devices, and that's where the device server stores that information. So now we have portability of the show itself, and the device server again is holding all the information about how to talk to the physical hardware, the cue sequencer could have 10 different shows programmed ready to go. Because the hardware is one-to-one, and the cue sequencer has all the shows. So again, portability of shows from venue to venue is accomplished by separating that out. The other thing that this accomplishes is hardware decoupling, a term that I refer to, meaning that, again, the show is not dependent on what that hardware is. So if we, for example, change out a video server, and let's say it's a 7sense Delta server, and we went, no, we're gonna, it's 5 years old, it's kind of on its last leg, we're gonna swap it out for a Pixera server. All we do is we go into the device server and we change what that command is that now communicates with that end device. It doesn't matter, the show could care less. The 10 shows that we program still say, play video track 1. And the device server handles, okay, now I know it's Pixera, I have to send this other command now to that hardware. So these are very, very powerful features to have, okay? It has a lot of benefits and can scale really well, but we have to look at how we take this software and make it redundant. We've already made the hardware redundant. How do we make the software redundant? Well, the triggering interfaces by nature are somewhat already redundant. You can have multiple touch screens. You can have multiple button panels. You can have time code and third-party controllers queuing show cues and queuing sequences. So if you lose a touch screen, it's not going to bring your show down. That's not going to happen. The cue sequencer, however, it's a process that's going to be running inside our show controller platform. So we need to have multiple instances of these processes running. And the same thing when we get down to our device server, we're gonna have multiple instances of the device server running. So that way, when a cue comes in and the cue sequencer takes it on the primary sequencer and says, okay, I need to fire off the video playback for video track 1, it passes it off to the device server, one of the device server instances, and then that talks to the hardware. Well, what if one of the device control services stops? We're fine because we have another one that's still running. Or maybe one's really busy and it marshals and it hands off from one to the other as we go. So that's a load balancing situation. So all of this comes together into an architecture that looks a little bit like this. And so let's take a closer look at what this diagram represents as our show control platform, our show control solution. We have over here on the left our triggering interfaces. Again, some examples being touch panels or time code, or a shot box is a network-based button box. So you can have go buttons and such that people can trigger from different tech booths or stage manager positions. And even, like I said before, third-party controllers, whether it be a lighting console or something like that, where they want to start off a show sequence from a lighting cue. So all of that comes into our sequencer column. When our show control sequencer, then there's 2 of them, remember, and they're going to load balance and marshal between them. Whichever one's available is going to handle that request, and then it's going to pass it along to the device server, one of the 2 device servers that we have running, and so on and so on. That goes down to the end devices and subsystems out in the venue and controls what they're doing. Now, if you look a little closer, and let me see if I can turn on our virtual laser pointer, you can see here that we are running all of these center processes on our server cluster. And we talked before about the hardware and the server cluster. So we have a primary host, which is a physical server, and we have our secondary host, which is another physical server, working together to create this server cluster, which is a virtual space for these to run in. And you can see that by default, we have one instance of these processes running on one physical host and one instance running on the other host. So this and the blue lines in between kind of represent how we're marshaling and handing off those requests from process to process as it goes through. So this shows how we're using the physical redundancy as well as the software redundancy in coordination, so that if we lost a server, if one of the processes somehow crashed or something, any of these situations, it's not going to bring the whole system down. We're going to be able to continue to run. So in the middle of a big show, you got 9,432 people in the seats, and all of a sudden one of your servers dies, you're going to make it through the show, and then you can deal with it afterwards. So you're not bringing down the house, if you will. So this is the concept of thinking outside the box. We don't have one point of failure. We don't have one controller. We have a platform made up of different pieces that work together, that are redundant, and that provide a very, very resilient and reliable system. So through this, we achieve a number of things. Again, it's highly resilient, it's highly reliable. Failures can occur, we can recover from them and keep going. It doesn't bring the whole system down. The network itself is redundant. The hardware we're running on is redundant. The software processes are redundant. The whole system is scalable. We can talk to 1,000 or more devices, no problem. We have the overhead, we have the communication bandwidth, we can handle all of this. And it's functionally decoupled into its core functions, and the portability factor and the separation of hardware from show queues just provides a very, very powerful set of features to deliver. So now that we have this concept of how we would go about doing a system this level, what does this take? What are the skill sets? What's the knowledge base that we need to be able to accomplish this? And kind of this comes full circle to where we are here today in the Fusion Studio, and the combination of engineering and entertainment and all these multidisciplinary interactions to provide the knowledge base and the expertise to design, deploy, program, and deliver a system of this magnitude. So this includes networking, it includes engineering, computer science, software programming, art and theater, audio, video, lighting. All of these disciplines work together to be able to deliver a solution of this level. So it's not just one person, it's a team of people. And the more of disciplines that you know and that go into it, the more valuable you are to the next generation of solutions. So that, in a nutshell, is how we would go about approaching designing and deploying a solution that is on a large scale that goes beyond a single entity controller. And as technology evolves and projects become more advanced and larger, this is the future. There's going to be more and more projects of this scale. And this is how we feel is the future of how to deliver a solid, reliable control system. And with that, I'm going to open it up to any questions you may have.
Jason, thank you. That's fantastic.
Yeah.
Yes,
Thank you.
absolutely. This is where I like to play, right? Controls, and I still get amazed by how deep and complicated it gets so quickly, right? But yeah, let's open up for questions. Lauren is in the back. She's going to monitor for online questions. Are there any questions here in the room?
When you're starting the process out with stakeholders, how much do you go into this redundancy with them, and how much do you sort of take for granted, I guess, when you're getting started?
That's a good question. It really comes down to understanding the requirements first. And no matter what system you're designing or how you're going to go about programming that system, because how you program also has to take that into account. It's really understanding the requirements, what the client is looking for. There are some projects where it's less critical, and there are some projects where it's hugely critical. So you have to take that into account. And there's a topic that I really enjoy discussing when it comes to understanding points of failure and reducing your points of failure. And there's and that's a great conversation for this afternoon if anybody wants to come to the coffee chat, in that you can never get rid of all points of failure, but you can move them. And by moving them, you move them from a more critical to a less critical point to make your system overall more reliable. Budget also obviously plays into it. You know, it's really easy to go to a client and say, we can make this fully redundant. You're never going to lose a show, but it's going to cost you X millions of dollars. And they're going to say, no, thank you, goodbye. So it's a balance. Yeah. You have to find the trade-off point of what is an acceptable failure and what is not, and what's the cost of that.
That's great. I really like the I don't know if it's a metaphor or analogy or the way of thinking about moving points of failure to other places. I hadn't thought about it that way, and I really like that.
There's a real simple analogy of redundancy in points of failure is a traffic light. When you are in a small town, you may come to an intersection where there's one light. Well, what happens when that red light burns out? You don't have a safety factor. So most cities, you come to an intersection, there's 3 or 4 repeated traffic lights. So that's a lot of traffic lights.
Sure.
But now you're safe. The percentage of chance of all of them being out is almost imperceivable.
Yeah.
So it's a great example of how to make something safe by being redundant.
Sure, absolutely. Other questions? Any questions online? None yet. They'll join us. They'll catch up and have some questions. Any other questions here in the room?
I got it.
Yes.
I really like the matrix that you showed. I mean, I couldn't see it very well, but what you're describing is a very complex interplay of different systems coordinated together. And what I took out of it, right if I'm wrong, is when you're doing a show, you start with the design or the creative vision that has to be engineered so that it can happen, and then you deliver it. But the point that you made me think more about is the reliability. And I don't think any of those are the most important, but maybe reliability is now up here where maybe I'm thinking about it down there. Would you agree that?
There's, I do agree, and especially in a case like this, where you're looking at a very large project that is very highly exposed. It's iconic, let's say. Again, like we do the show control for the Radio City Rockettes Christmas show, and they would not be too happy if a show did not go on, right? So we have redundant systems there, and I think that reliability plays into not only your system architecture, but the selection of the pieces in the architecture. And so, you know, you want to make sure that what equipment you're using has a good track record. It's reliable in itself. You don't want to use, let's say you want to run a piece of software, QLab or Media Lawn Manager on Windows. Actually, QLab runs on Mac, but point being, you know, if it's Windows, you're not going to go out and buy a desktop PC and run your show on it. You're going to want to go order a IT server that's made to run 24/7. That's reliability within the item itself, and that plays into the overall reliability of the whole system.
I think it's worth maybe just unpacking some math, right? So this imaginary venue is 10,000 seats, right? I have to imagine tickets are certainly north of $150 a pop, probably more like $300 a pop, right? Does that seem right?
Probably for a show like that, yes.
Yeah. So you're talking, let's say even just half capacity. That's 5,000 seats at $300 a pop. How much? Someone do that math really fast. Anybody? 150 grand. I don't want to refund that show,
right?
Because the system, you know, burped over something, right? That's really what you're talking about. Is there's a huge return on investment question. Yeah.
And beyond building your system to be reliable, it's always the thought again of what's our backup plan? And how do we not cancel the show because something just freaked out?
Yeah.
How do we go on? How do we move forward? So and this is what I'm talking about when I'm talking about programming as well. Like what's the style of programming? How do you go about architecting your programming scripting so that you have flexibility built in? You are thinking, you're checking different feedback points to see, you know, can I do this? Can I move forward? You know, do I do something else instead? It's on all levels.
Absolutely. There's I talk about this in some of my classes. Cirque du Soleil has a big practice of this where, you know, they'll rehearse 6 days a week. 4 or 5 of those days are the days where things are deliberately rehearsed that go wrong, so that you're rehearsing the alternative plan in the moment, right? And so Trevor over here is going to be faced with this soon. He's automating a turntable for a show. He's got to have alternate staging worked out with the team. And there's a dress rehearsal where I'm going to show up, and they're not going to know which day. And I'm going to tell the operator, it doesn't work today. And they're all going to have to respond in the moment, because you have to keep the show working.
Right. There will be a day when that motor fails.
Right.
Then what do you do?
Better to prepare for it than to hope that it doesn't. Were there any questions yet online there, Lauren? Oh, my online friends, you're killing me. Join us. Ask some questions, Kevin.
Yes.
That kind of model build into like redundant systems?
No, absolutely. It's a good question. One of the things that we offer is service contracts to extend, warranty and support. And we include in that proactive checking of the system. It's always better to know ahead of time when something is starting to look like it might fail. Again, like overheat is a big one. Temperature checks, things like that. For computer systems, is a CPU running hot? High is memory usage running high? Do we have software has a memory leak or something going on? We try to catch it before it actually fails. So it's monitoring that data. Again, we're back to data again, monitoring that data, getting that feedback, and then understanding your system, as well as, knowing the age of the hardware, knowing, in the old days we had projector lamps. You monitored your lamp hours. Oh, this one's getting pretty high. It's time to swap it out.
Yeah.
But even with computers, how old are these hard drives now? What's the likeliness of them failing now? Do we proactively swap them out so that we know we're safe for another 5 years or so, and not rely on a 10-year-old hard drive to keep running? Yeah, for sure.
Does that answer your question? Yeah. Other questions? Lauren, what do you got?
For newer projects that will run for a long period, are you typically hired by the owner of the facility or brought in by the show designer?
Very good question. Our direct clients come from a number of different places. So sometimes we are brought in from clients directly to work with other teams to produce a show or an exhibit or an attraction. Sometimes we're brought in by the third-party designers, producers, directors, those kinds of level people. And sometimes not until it gets to the AV integrator. So a company is hired to come in and install the racks of gear, and they call us up and say, hey, we need some programmers to come in and put this together and make it work. So it comes from all levels. I would say, to the context of that question, the longer running exhibits, shows, attractions, projects, the larger and longer projects, we tend to be involved earlier to help navigate how the system would be designed to deliver what they want, and then work with, again, the teams along the way, and sometimes even act as a consultant to those end clients to know that, well, you want this type of a system, we'll help you put that out to bid for the installers and help you make the right choice of who's going to be a great installer to put this kind of system in.
Sure. I suspect I know the answer, but to follow up, where do you prefer to become involved? Do you prefer to sort of be involved from the very beginning, or where is it easiest, I guess?
Right. I would say that the general answer is earlier the better.
Sure.
Absolutely. Doesn't always work that way between just the way projects evolve and budgeting and so forth. It doesn't always work that way. I always love to get in the beginning so that we can help during that whole conceptual phase to help steer and answer and consult with where it's going, what's possible, what's not possible, how can we deliver on this. What we don't like doing is to come in late to a system that someone put together and then realize, yeah, but what you're asking the system to do, it's not quite going to do it.
Right.
So we can't give the client what they want because our hands are tied, because what they put in can't quite deliver.
Sure.
But there are other times, like I say, when we're just called in to go and program a museum, and that's fine. But from design and delivering a solution, absolutely from the beginning.
Sure. More questions online. There we go. I knew they'd show up. There we are.
How much work does implementing tools and functionality ongoing monitoring and feedback versus
Right. So what I touched on briefly in the presentation was monitoring, right? again, it's so important to be able to know what's going on in your system, to monitor all of that feedback. And so we do a lot of programming in order to monitor things. And I would say that on average, a lot of our projects are as much monitoring as anything else. Again, we do a lot of museum work and experience work and kind of public space work. Live shows happen, Radio City and so forth. This case example would be kind of a live show arena. But a lot of our work is more facility based. And with that, there's not a lot of live show queues.
Sure.
But there's a lot of, let's get this attraction up and running in the morning, let's shut it down at night. And in the meantime, let's monitor and make sure everything's doing what it's supposed to do. So we did a project in New York for a large IT company that, kind of tied into this a little bit, in that we're monitoring over 1,000 devices.
Wow.
We are controlling a third to half of them. Somewhere between 300 and 500 devices. We're actually controlling what they're doing. The rest of them we're just monitoring, but we're monitoring over 1,000 devices. And how do you take that amount of information, that amount of data, and make it easy to interpret to a human? So what is that interface? How do we present that information? How do we roll up hundreds of projectors and LCD displays and playback and video looping and audio stuff that's going on to screens, user interaction, to where they can say, yeah, everything looks okay, or no, it's not okay, but how quickly do we get to the point of where the problem is? So we spent a lot of effort, a lot of time in developing those kinds of solutions.
Do we have more? Okay.
There's definitely been a few. And dare I say that our horror stories are usually not because of us. I mean,
It's good to be able to say.
Exactly.
Yeah.
I would say that most of the time when projects go off the tracks, there's a lot of other things that come into play, and it's not because we caused it. And, thankfully, but we kind of get stuck. If you have, in the show control world, show control touches everything. So you wind up getting involved in everything, and you're also the last one standing. So the lighting people come in, the audio people come in, everybody comes in, programs their show, and they walk away, and you go into rehearsal. Well, first of all, if construction of the space runs late or other things run late, your time that you're going to spend programming everything just gets shorter. You're the one that gets compressed. And then when things don't work, always blame show control first. It doesn't work. Well, it's show control fault.
Sure.
Usually it's not. Usually it's something else. Usually it's, whether it's something wrong with the in device or the network or something like that. But we've unfortunately been challenged with some less than stellar experiences. And, you work to invest you can and try to come up with a way to provide a solution to the issue at hand and make the best of it. But yeah, it happens. Not everything's rosy. That's for sure.
Sure.
Yeah.
Awesome. Thank you for that. There's two more here. You and then you.
So at least at the scale that I'm used to working at, the sort of design scope and concept can change fast and towards the end of a project. You find that your out of the box approach through this flexibility anywhere? I know we're talking about how it's scalable, but in terms of the duration changes, like that, you find it depends anywhere?
No, actually quite the contrary. We understand, we know from history and experience that things change throughout a project. And both from the solution itself and from how you program it, you don't ever want to put yourself in a corner. So we try to always keep in mind that they're going to change their mind. Something's going to change. The client's going to say, no, I don't like that anymore. Let's change it to this, or, let's change these cues or whatnot. With this approach, with this case study and this kind of approach to things, one of the advantages is that it does make it really easy to, when it comes to queue timing or duration or what that device is, we need to change the command we're sending it. Those are all elements you could go in and change. There's a lot of flexibility. There's a lot of power to it. We try, when we're designing solutions and systems, to keep it fairly flexible. And again, sometimes that has a cost factor, but we definitely don't want to pigeonhole us into something where we get to site and the client wants to change his mind and we're like, we really won't do that. Try very hard to work to not do that.
Does that answer your question?
Yes, thank
Right.
So, Professor the question I have is, for the students and young professionals that are viewing this, what do you recommend they do to help get this experience without necessarily always having access to large scale projects and budgets?
Sure. Yeah, because you don't have that,
Yeah,
right?
yeah,
For
right,
sure.
yeah. I can
Um,
only generate so much here, but I can budget for them.
it's from our experience in hiring and the skill sets and the abilities of people that we work with. It's really about the concepts and the fundamentals. And, again, I came from engineering, went to theater. We've hired quite a few people out of schools that had hybrid programs. It seems to work really well because they are exposed to different things. What I look for when hiring is not what you've done, but what I see your potential being. So you may not have touched a large show before, but if you get it, you understand the concepts, you understand the thought processes, you understand certain programming, I know you can pick this up easily and you can pick that up and you're going to be able to grow with that and kind of implement the thoughts on a large scale once the opportunity is there. But no, you're never going to have that opportunity during your schooling.
I want to build on that thought a little bit. So one of the things that you touched on was this notion of redundancy. And I found over my career, both with students and in industry, that not everyone has a mindset to think about redundancy. So going beyond discipline, what might be some of those other mindsets that would be valuable in this domain? Agnostic of what discipline you come from, what are those valuable mindsets that maybe students can work on developing?
That's a great question. To me, it's the ability to conceptualize and to understand concepts. No matter where you come from, what your training is, if you can think outside the box and you can understand new concepts or a concept that's unfamiliar to you, then you have that mental capacity to be able to grow into that and to be able to move in whatever direction the industry tends to go. It's like we were talking about earlier today, the technology industry is growing, right? It's not going backwards. And the industry as a whole kind of has a hard time keeping up. The entertainment industry, the AV industry tends to lag behind IT as far as that level of knowledge. Sure. When networks came over into entertainment, it was like, oh, networks. Now we're at a point where it's not just networks. It's highly managed, highly advanced networking. Because you're talking about audio streaming, video streaming, control applications that are very timely based. You're talking about time syncing over the network. So the technology is going to continue to grow. And in order to get there, we need smarter and smarter people to design those and to make those. And for Disney and Universal and places are always trying to come up with the latest, greatest experience. You need great minds to be able to do that. And so wherever you come from, whatever applied science or mathematics or computers or whatever wherever you're coming from, if that mindset is there of I can understand concepts. I can understand how to get from here to there. I think that opens up an opportunity to grow into that. If that answers your question.
I mean, it sounds like what you're describing is what is sometimes called a growth mindset, right? And I mean, I know it's a challenge. Mary, who asked the question about mindsets, and we talk about this often. I can't chase the technology fast enough.
Correct.
To teach all the things that I want you to learn before you leave. But if I can teach you that you're competent enough to figure out the next thing and how to figure it out, then you're in a good spot.
Exactly.
That's kind of what you're saying,
Exactly.
right? Yeah.
And even, as an example, even in our company, we're a niche company. We specialize in something. We have very smart people that are specialists in the industry. But even looking at us, every couple of years, we're reshaping, we're redirecting, we're moving. We start off using these products, and then now we're going in a different direction. Now we're developing stuff like this. Well, what are the processes? What's the software that we're using to run these processes? How do we marshal those communications? Where are we storing that data? Where in what database are we using?
Right.
To be able to store that, all things that aren't common to an AV industry yet. But we navigate and we talk every so often about, well, where are we focusing? Are we focusing on these types of solutions? Do we still focus on the small projects? Where do we go with our team? What expertise do we need to have on our team to be able to continue to take on these types of projects? So, and it changes constantly. So not only do you have to be flexible and have that growth mindset to get in the game, but it doesn't stop. It's just like you're learning for life.
Yeah.
And even we're evolving for life.
We were talking yesterday when we were walking around our theater buildings. We both learned how to edit sound on reel-to-reel tape, and had watched. There was a huge explosion of digital media from like the mid 90s through the 2000s, and we both had to try to keep up, right? And it kept changing. And every time we thought this was the new thing, nobody in here remembers. Maybe somebody on the live stream will remember Super CD. Do you remember Sony Super CD? That was going to be the thing. It's not the thing. It's disappeared. Or every studio was going to have Firewire. Do you remember this? Every sound studio was going to be Firewire. It's not a thing. Anyway, you can't keep up. There was another question online, I think.
Well, it is an interesting name. It's a catchy name. And as the story goes, I will put it this way, that early on when the company was first formed, they were working on a project over, I believe in, I think it was Abu Dhabi or someplace internationally. And the few gentlemen that had started the company were constantly running around because everyone kind of learned that, oh, those guys are really smart. We have a problem here. We need this address. Go get them. And they're constantly running around. And they started being referred to as grab one of those monkeys that are running around everywhere. So the thought was, well, if we're going to be smart, if we're going to be monkeys, we should be smart monkeys.
There you go.
And so that's what has kind of stuck with the company name.
I dig that. That's great. Are there any other online questions? Any other questions here in the room? I think we're just about at time as well.
Okay.
So that's great. Jason,
Great.
thank you so much. This was great
Thank
to have
you.
you here. Thank you all for coming. I want to encourage everyone to mark their calendars for the middle of July. Lauren, can you remind me the dates for the symposium? July 28th to 29th for our annual symposium on education and entertainment and engineering. Keep your eyes open for more information about that in the coming weeks. Next month, we'll be joined by our two guests, Denise Shase, I think I got that right, and Josh Montgomery. They each have different ways of incorporating robotics, the entertainment industry, and performance to introduce students to STEM concepts. So be sure to register so you can have a chance to program your very own R2-D2 from Star Wars in the room, and to collaboratively create a play for Denise's robot performers in her robot theater in Iowa. Thank you all very much. Have a great day.